Okay, after we have gone through that question, this exercise become really easy. Yesterday I have include most of the content already in this exercise. So like most of the exercise I've talked about in yesterday. So what we talk about here is still the area under the curve. What we have done yesterday is just give you an equation and ask you to evaluate. Okay, give you an equation and ask you how to anti-diff, how to sub values. This talk about the calculations basically. But like I have talked about the meaning of the find the area under the curve. So if you think about the area, well, I have sketch fx, and the area you want in between a to b is all above the x-axis. Okay, all above the x-axis. I can just say a to b of fx. Well, that's what we know. We already know yesterday. Or if everything is below x-axis, okay, everything is below x-axis, I can say there's, okay, I have couple of ways of doing that. Okay, to write about this, I can say there's negative a to b of fx dx because I want the positive area. So that can give me a to b give me negative, and the negative that give me positive. Or that will equivalent to b to a fx dx. Okay, so like you change the two upper limits and lower limits, the order of that, and that will give you positive as well. Okay, I'll talk about this one later. This one, the first two, we talk about all above or all below. And now let's talk about a mix, okay, a mix of area. So what we have is a to b is above and b to c is below. When I see the graph, I know this should be a to b fx. Well, I can plus c to b fx dx. Okay, that like you change the upper limits and lower limits, that still give you positive. Or I can say that's a minus b to c of fx dx. Okay, so I can go for those two methods. But the very important thing here is some above, some below. How can you know some area is above, some area is below? You need to see the graph, right? I need to see what the graph looks like. I need to find all the x-intercept, like, and then I can say, oh, from here to here the area is above, and from here to here the area is below. I need to see the diagram. I need to see the shape. Okay, otherwise, I also need to know the x-intercept. Otherwise, like I can't work it out. But if you have your cats, that's really easy to deal with. Okay, remember the absolute sign I have talked about. I said like in methods course we no longer talk about that, but I can use it. Okay, if you want to just check your answers in part 2 exam, I can't really use it a lot now because they're trying to limit the number of questions they have for those time. But you can still use it. For example, I want to check for something. Okay, I still do as my normal way, but I can check my answers by using calculators. So what I can do, if I just say find the total area in between 2 points from A to C, okay, just 2 points. I don't know whether the graph is above or whether the graph is below. I don't know the shape of the graph. I don't know any x-intercepts. How I can find the area directly without using the graph? What I can do is, okay, any function. Well, it can be all above, it can be all below, it can be a mix in between the point you want. You just put the function in, but put absolute sign around that. Okay, what's the absolute sign doing? Is flip the negative graph to positive. So, show you example. This is my original graph. Okay, this is my original graph. And I want the area in between A to C. Let's say I want this area. Okay, let's say I want this area. So can we see? I want these two areas and say the middle points. I don't know where is it. Let's say I'm not labeling it. So I just want those total area. Okay, this total area. So if I put absolute sign around fx, okay, this is the fx function. What's the absolute x function looks like? The graph reflects by the x-axis. All the negative will be reflected positive. So what it will look like, I will use a pink one. Which one distinguish that? Let's use a black one to sketch. So the positive still stay as positive. Remember I said absolute positive still stay as positive. Negative will become positive. So okay, it's symmetrical reflection. Well, my one is not that symmetrical, but it's something like this black graph. It's something like this black graph. So the function now looks like this. Okay, the function now looks like this. And then if I talk about this black function f absolute x, I talk about the area in between A to C. What it looks like is, use the pink one. Point A is still here. Okay, C is still here. So now it's this area. Okay, A to C under the f absolute function is the same area. The pink area is the same as the red one because the positive one still stays as the positive place and the negative one just be reflect up and you have a positive one. So from A to C now is all positive area. There's no negative. So that's why I can absolute the function and just fine. Okay, you absolute inside. Okay, in between the integral and the dx, you absolute the function, not absolute from the outside. So it's inside. So give you any function, you don't need to sketch for it. Like you don't need to work out x-intercept. So what all you need to do is where you want to start, where you want to finish, and put absolute sign around the function. That will give you the total area. Okay, this one is the total area, not the sign area. Okay, it's the total area. Okay, let's have a look at examples below. Okay. So write down the integrals represent the area. So for the first one it's all positive and I can see it's from 0 and 3 of that function. So I just write 0 to 3. 3x minus x squared dx. Because it's all positive, I can directly write it out. So this will give me 3 over 2x squared minus a third x cubed. 0 to 3. Okay, 3 over 2x squared minus a third x cubed. So I put 3 in. That's 3 over 2 times 9 minus a third times 3 cubed is 27. Minus, you sub 0 in, you have 0 minus 0. Okay, so f3 minus f0. This is minus 9. 9 is 18 over 2. That gives you 9 over 2. Okay, that's 1. That's A. Okay, so B. B is all negative. Okay, it's all negative. So I will go for 4 to 0. Okay, I'll go backwards. 4 to 0 because it's all negative. X squared minus 4x dx. That's a third x cubed minus 2x squared. 4 to 0. Okay, careful with the order. You always sub the top one first, and then you sub the bottom one, and you subtract. So, well, you sub the 0 in, that's just give you a 0. And minus, you sub 4 in. 4 times 4 is 16. 16 times 4 is 64. Minus 16 times 2 is 32. And that gives you minus 64 over 3 plus 3 times 96. And then I can subtract 32 over 3. Okay, those two are easy because it's only positive area or only negative area. It's easy to set up the equation. Okay. I also talk about C. Okay, not this question is easy, but I also talk about the function properties. Is this an even function or odd function or neither? If I ask you to prove it, how you can prove it? Is that an even function or an odd function or neither of that? Okay, think about what's even function. Okay, even function is that what? F negative x equals to fx. What's an odd function? What's the formula for odd? F negative x equals to negative fx. So even function is f negative x equals to fx. Odd function is f negative x equals to negative fx. So basically, doesn't matter whether it's odd function or even function, I need to see what f negative x equals to. Okay, what f negative x equals to. So I will say this is fx. I'll say this is fx. Now I want to think about what's f negative x. Okay, in this case, f negative x equals to negative x squared minus 9. Okay, sub x with negative x. And then there's a negative x times x squared minus 9, because minus x squared is still x squared. So now what we can see, that's a minus times fx. So everything still stay the same as this fx, but you have a minus sign in front. This is symmetrical about the origin. Okay, it's symmetrical about the origin. Okay, because it's symmetrical about the origin, those two areas will be the same. Can you think about that? Well, it's exactly bound by the same place, like negative 3 to 0 and 0 to 3, and it's symmetrical about the origin. So if you think about the sign area, that will be a 0 sign area because cancelled. So now what I can also, well, it must be an odd function, then I can see that's same. If it's not an odd function, I can't say the same thing. So what I can do is only find half of it. Okay, I can find half of it, and then I can just times 2. So one way of doing this is 2 lots of, well, I can just from -3 to 0. Okay, -3 to 0. Or 3 to 0 will be the same. Or 3 to 0 will be the same. 3 to 0 will give you a positive region as well. And then, because I want to anti-diff, I will better expand it. Okay, dx. That's 2 lots of 1 over 4x to the power of 4 minus 3x to the power of 3. Okay, so what I will have here is that's 2 lots of, well, you sub the first, well, this is a square bracket. I sub 0 in. Okay, I sub 0 in. That will give me 0 minus 0. And minus the second function, sub -3 in. That's 81 over 4. That's a, is that a, oh, it's 9x. That's 9x. That's a 9 over 2x squared. Yeah, thank you for that. I'm just thinking where's wrong because the value seems like to be a positive, negative. Yes, it's 9x. Where I get the square from? Okay, sub 0 in, get 0, and get 3 in, that's a 80, -3 to the power of 4 is a 81 over 4. And that's a 9, that's a minus 81 over 2. Okay, 3 squared is 9, 9 times 9 is 81, that's 81 over 2. And that's 2 lots of, what I can see here is 0 minus 81 over 4, and then plus 81 over 2. So inside is 81 over 4. If you calculate 81 over 2 minus 81 over 4, that's 81 over 4. So a half of 81 minus a quarter of 81, you're left with a quarter of 81. And then times by 2 is 81 over 2. 81 over 2, times that by 2. Okay, again, integral is shift plus. Let's say I use calculator. I don't care about anything. Even function, odd function, I don't care. Just start from -3, finish at 3. Okay, domain, like limits is -3 and 3. Put absolute, oh, not here. Here, absolute. Okay, absolute sign and type the function in. So what function we have is x cubed. X cubed minus 9x of dx. Okay, so I don't care about what function is that. I just absolute the whole function, flip it all up, and I just want the domain start point, finish point. Press enter. I have the same answer here, 81 over 2. Okay, so I just show you how you can use calculators to directly get answer. If it's 1 mark multiple choice questions, you know the function, you know the start point, you know the finish point, directly enter that into the test. The absolute sign is next to 9 and the row, second row, first one. The second row, first one. Okay, so I can write it here for you. I can go for integral -3 to 3 absolute of x cubed minus 9x absolute dx, and by cas. Okay, that's another way we can do it. Okay, let's have a look at example 2. Example 2 asks us to sketch for the graph y equals to 2e negative x minus 3. Okay, revision on exponential graph. So we have x-axis and y-axis. Y equals to -3 will be the horizontal asymptotes. Okay, y equals to -3 will be the horizontal asymptotes. Okay, when x equals to 0, y equals to -1. Okay, I have y-intercept here. When x equals to 0, e to the power of 0 is 1. And then 2 times 1 is 2, 2 minus 3 is -1. So I have 0 minus 1. And think about the shape. Base is e. E is a number greater than 1. So I have this shape. And because it gets -x, it will get reflected by the y-x-axis. So you should have this shape. Okay, so I have kind of a graph looks like this. And also I want the x-intercept. So x-intercept is when y equals to 0, 2e minus x minus 3, 3 equals to 2e minus x, 3 over 2 equals to e minus x, minus x equals to log e 3 over 2. And x equals to minus log e 3 over 2. Or I can say that x equals to log e 2 over 3. Put the -1 as the power of 3 over 2. Flip it. So that can be 2 over 3. So which is this point here. And that's 0 minus 1 at this point. Okay, so that's the graph. Okay, you must know how to sketch exponential. It's quite helpful graph. The area, find the area of the region bound by the curve, like this curve. The x-axis and the line x equals to -2 and x equals to 2. Well, it's easy to sketch x equals to -2. Okay, that's x equals to 2. Okay, and then x equals to -2. Okay, x equals to -2 is this one. Well, how I can know is on the left-hand side of the x-intercept, or how I can know whether it's on the left-hand side, right-hand side of the x-intercept. So where is this -2? Well, I don't know what's the size of log e2/3. Like, it can be -2, like can be -3, can be negative point something. So how I can decide where is -2? So one way to think about this is I can sub x equals to -2 into the function. So y should equals to 2e2 minus 3. You know, like e is about 2.7. Well, let's just think about this 2. 2 squared is 4. 4 times 2 is 8. 8 minus 3. That number is still positive. Okay, it's still positive. Because it's positive, it must be on the left-hand side of the x-intercept. It can't be on the right-hand side. If it's on the right-hand side, you have a minus value. But this coordinate is a positive value. That's -2, 2e2 minus 3. Okay, so it's a positive number. So it must be on the left-hand side of the x-intercept. But I can see also from the scale, it must be like on the left-hand side. But just want to confirm what you should do. You can sub the point in to see where's the coordinates, positive coordinates or negative coordinates. So the region I'll talk about is this one and this one. Okay, that's the region bound by the blue curve, black x-axis, and the 2 red vertical line. Okay, that's the region bound by those lines. So x-intercept here is -2. This point is 2 here. So if I want to write about the region, okay, the region, I will go for -2 to log e2/3. Okay, so of 2e minus x minus 3 dx plus 2 to log e2/3. Okay, because it's negative region, start from right hand side to the left hand side. 2e minus x minus 3 dx. Okay, that's the hand approach. Okay, so this is doing by hand. I can also just say that's -2 to 2 of 2e minus x minus 3, put absolute values here, and then I will dx the function. Just put that into the calculator. I don't have time to go through the hand approach working with you, but let's see what the answer should be. 2 times e to the power of minus x minus 3 dx. Okay, that gives me approximately 11.48. Okay, approximately 11.48. Well, it's not exact because e is not rational numbers. I can't express it in the exact way by doing this. So I'll say that's approximately 11.48. So what I want you to do, you have 3 minutes now, and also anytime like during the weekend, I want you to try hand approach to anti-diff that and sub the value in. After you work out the final answer, you should have exact answer. Okay, you should have exact answer. It's not going to be approximation. So you have exact values. Put the exact value into the calculator and control enter to see is that the same as 11.48. Okay, do we have the same thing? If you have the same thing, which means you get the correct value. Okay, so try to evaluate this by hand. Okay, so how this equation has been set up. Talk about the area. Okay, top area, plus the negative of the bottom area. Okay, so try the exact. And the calculator one gives you 11.48. Okay, approximately 11.481 something. So by CAS. Okay, by CAS. Any questions? Okay, if you don't have any questions, that's it for this week. And next week we can finish it.